assignment number 16, notes on horizontal tangents and rates of change. Okay, so what we have here is we're given a function and it's asked to determine the points, the x and the y coordinate, so an ordered pair, at which the graph of the function has a horizontal tangent line. If the function does not have a horizontal tangent line, say so. Okay, so the first thing we need to talk about is, what does it mean to have a horizontal tangent line? Okay, so if you have some graph, I'm just going to draw just some random graph up here. Okay, a horizontal tangent line means where is my tangent line horizontal, meaning the slope is 0. Okay, so really a lot of this stuff that we're doing early on is really just interpreting what the question is asking, and the question is just asking, where is the derivative 0? Okay, horizontal tangent line means the line where the slope is 0 and slope is derivative. Okay, so we're going to find our derivative first. So number 1, y equals x squared minus x. Our derivative is 2x minus 1. Now we're going to set our derivative equal to 0. Remember, our derivative function is a slope. 2x equals 1, x equals 1/2. Okay, we're halfway home because we have the x coordinate of our point, 1/2. Okay, we're going to take that x value and plug it back into our original to get our y coordinate. So it's 1/2 squared minus 1/2, and that's going to give us negative 1/4. Okay, so we have a horizontal tangent at 1/2, negative 1/4. And I just want to quickly show you this. I did this in class, so I'm going to go ahead and do it again here. Is if I graph the function x squared minus x, probably need a better window here. All right, we'll hit zoom 6. And we get our graphs quadratic. Okay, we know that this is a quadratic, and we're going to have a horizontal tangent line at the vertex, or what we would call a relative minimum or a minimum. Okay, so I'm just going to find my minimum. My minimum better be 1/2 negative 1/4, or I did something wrong. Okay, so we're going to hit second trace and pick option 3, minimum. And then you can move your cursors, or I like to type in numbers. I know it's somewhere between negative 1 and 2. Calculator marks 2 spots. I hit enter, and sure enough, 0.4999999 is 1/2. And then your y coordinate, kind of hard to see, it's getting a little washed out. Let's see if I can darken that up a little bit. That's about as good as I can get, but trust me, that says negative 0.25 right here for the y coordinate. Okay, so sure enough, we have a horizontal tangent at 1/2, negative 1/4. All right, number 2, find our derivative, 2x, set our derivative equal to 0, and obviously get x equals 0. Plug 0 back into the original. 0 squared plus 9 is 9. Okay, I don't need to graph this one in my calculator. I know the graph of x squared plus 9 is a quadratic that shifted straight up 9. Looks like that. And there's my horizontal tangent at the point 0, 9. All right, number 3. Y equals x plus 4e to the x. We'll find our derivative. Y prime is equal to 1 plus the derivative of 4e to the x is 4e to the x. Okay, we're going to set 1 plus 4e to the x equal to 0 and solve for x. So that gives me 4e to the x equals negative 1. E to the x equals negative 1/4. Okay, and I can go ahead and stop there. You could do a log rule and get that into x equals form, but I know that there is no number that I could plug into x and get a negative number back. Even when I plug a negative number in for x, I'm just going to get 1 over e to that positive number that you choose. So there's no way that this will work. Therefore, there are no horizontal tangents on this graph. Okay. Another way to look at it is the graph of x plus 4e to the x is an increasing function. all the time. So you can go ahead and graph that and you'll see that it's never going to have a horizontal tangent. All right, number 4. Find our derivative first. The derivative of cosine is negative sine, and the derivative of negative x is negative 1. And we're working on a restricted domain here of 0 to 2 pi. All right, so set negative sine x minus 1 equal to 0. We get negative sine x equals 1. Divide by your negative and you get sine x equals negative 1. Okay, flashing back to trig days, pre-calc days, is where is sine equal to negative 1 between 0 and 2 pi? And that answer is at 3 pi over 2. Okay, so our x-coordinate is 3 pi over 2, and our y-coordinate is plug that back into this. The cosine of 3 pi over 2 is 0 minus 3 pi over 2, so our answer for our y-coordinate would be negative 3 pi over 2. Okay, just a couple of different types of functions, different kinds of examples of finding horizontal tangents. We know that the cosine graph looks something like that, right? So we know we have horizontal tangents all over the place on the cosine graph. That's why we restricted this, because there's technically infinite of them, okay? All right, so we have seen how the derivative is used to determine slope, and the derivative can be used to determine the rate of change of one variable with respect to the other, okay? The next bullet point tells you that just some couple of examples of when we're going to use this, okay? Applications involving rates of change in population growth rates, production rates, acceleration and velocity, okay? And we're going to use the acceleration and velocity a lot, and we're going to get into a little bit of that more today, okay? A common use for rate of change is to describe the motion of an object moving on a straight line, okay? So a lot of times you're just going to have like a horizontal axis, the x-axis, and a particle is just going to be moving back and forth, or an object is moving back and forth. I know I've seen a problem where there's a horse tied to a fence and he's just moving left and right, okay? Or a particle moving back and forth, like I said, okay? It's customary to use horizontal or vertical line with these. Usually we're going horizontally, but every once in a while we go vertically. So this touches on that right here, okay? On such lines, movement to the right or upward is considered to be in the positive direction, and movement to the left or down is considered to be in the negative direction. It's just common sense. If you just think about sorry about that, I had that too low. Just think about a XY axis, right? To the right or up is positive, to the left or down is negative. All right, the function s that gives us position relative to the origin of an object as a function of time, t, is called a position function. And a lot of times they'll use s, or they're going to use s of t. Okay? That's our position function. Meaning, where'd we start? All right, let's go ahead and flip it over. Okay, so we've talked about this before, okay? The average velocity, and that's in your foldable already. If not, ask me about that, and I will, I'm sorry, I'm too high again. The average velocity, okay? We put it in our foldable, and that formula was f of b minus f of a over b minus a, which is just going to say right down here. But what that is it's the change in distance over the change in time, or delta s over delta t. Okay, remember, s is our position function, so the change in position or change in distance divided by the change in time is average velocity. Okay, another way to describe average velocity is this: it's the slope of the secant line. We also wrote that in your foldable. Okay, that's all. This is all in one box on your foldable at the very end. I don't have my foldable with me, or I'd show it to you. All right, and now today we're going to get more into this instantaneous velocity. Totally different from average velocity. Instantaneous velocity is going to be the slope of the tangent line. Okay, and the slope of the tangent line is our derivative. All right, so this next example here is doing average velocity. Okay, average velocity is simply just the slope you've been doing your whole life. Okay, just y2 minus y1 over x2 minus x1. Okay, this is not an ordered pair, but it is an interval of, let's read this here. We got a billiard ball that's dropped from 100 feet. Its height, s, at time t is the position function. S equals negative 16t squared plus 100, where s is measured in feet. That's the distance the ball is dropping, and t is measured in seconds. Find the average velocity over each of the following time intervals. So from 1 second to 2 seconds, we're going to find the average velocity. Okay, so the first thing we need to do is, is find the y value when t is 1. So we need to find s of 1. Okay, and we're going to plug 1 into this, our original function here. So we have negative 16 times 1 squared plus 100. And that's going to be equal to 84. And then we're going to find s of 2, which is negative 16 times 2 squared plus 100. What's that there? That's 4 times 16 is negative 16 is negative 64 plus 100 is 36. Okay. Now remember, the x or the t value is 1. The y or the s value is 84. And same down here, 236. And we're just going to do y2 minus y1 over x2 minus x1. Okay, so that's just going to give us 84 minus 36 over 1 minus 2. And that's going to be negative 48. Okay, although it doesn't say it, typically, or from time to time, you're going to be asked to give units. Okay, and so this is negative 48 feet, because s is in feet, says it right here, and that's feet per second. Okay, so that ball that we dropped is dropping. Okay, the negative indicates a downward motion, right? So negative 48 feet per second, or it's falling at 48 feet per second. Okay. In general, if s equals s of t is the position function, okay, it's either going to say s equals or s of t for an object moving along a straight line, then the velocity, okay, and that's what we just found up here, right, the average velocity, but now we're going to find instantaneous velocity of the object at time t is s prime of t, or in other words, velocity is the derivative of position. Okay, and that's this right here. Velocity can be negative, 0, or positive. Okay, now we're going to talk about speed. The speed of an object is the absolute value of velocity. Okay, so if you're a physics person, you should be able to recognize those few terms. Okay, speed is never negative. Just think about your car. Okay, even if you're driving backwards, you're not going in negative speed. All right, so number 6, we're going to put all three of these things into play here. A particle moves along the x-axis according to the position function s of t equals 3t minus 3t squared. Determine average velocity. Okay, average velocity is delta s over delta t, or delta s over delta t, or change in distance over change in time. Okay, from time 0 to 2. So we obviously have to find s sub 0, s of 0, not sub 0. So plugging 0 into this, we're going to end up with 0. And then we need to find s of 2, which is 3 times 2 minus 3 times 2 squared. That's what, 6 minus 12, so that's negative 6. Okay, so we have the two ordered pairs 0, 0, and 2, negative 6. And we just find our slope. That's negative 6 minus 0 over 2 minus 0, which is going to give us negative 3. Okay, that's the average velocity of this particle moving. Okay, now we're going to determine the instantaneous velocity, which means what is the velocity at the exact moment time equals 2 seconds. So the first thing we need to do is find our derivative. Now you're going to see me write this out several different ways, because there are several different ways to write it. But instantaneous velocity is the derivative of the position function, which is s prime of t. Okay? It is not wrong instead to write v of t. V meaning the velocity function. So the derivative of position, the derivative of s, is velocity. You do not have to write both of these things. One is good enough. Okay? So the derivative of our position function is going to be 3 minus 6t. And we're asked to find the instantaneous velocity at t equals 2. So either s prime of 2 or v of 2, again, they mean the same thing, is equal to 3 minus 6 times 2, or negative 9. Speed is the absolute value of velocity. So the absolute value of v of 2 is the speed at time t equals 2, and that would just be 9. All right, I'm not going to do this one. It's just the same type of problem. Okay, it's a marble rolls up a smooth inclined plane. After t seconds, its distance from the starting position is given by this position function. Find the velocity of the marble at t equals 3.1 seconds. You're just going to find s prime of t, and then you're going to find s prime of 3.1. All right, the last thing is we are given a position function. Okay, the graph below represents the distance in meters an object travels over a 10-second time interval. Sketch the velocity function. Okay, sorry I didn't draw a graph in for you. I didn't even think of that. I have this graph, and I could have put a blank one over here. I'm just going to label this 1 to 10 seconds, just like the position function is labeled. And I'm going to label like 1, 2, 3 up here, and -1, -2 down here. I know I don't have to go further than that. Okay, over here, okay, now we're doing the velocity function. So this is going to be our velocity, okay, and still down here is time, okay. Remember, velocity is the derivative of position, or the graph of the slopes of the position, okay. So notice when you're given these, you're never going to get a curve, okay? Especially if you're just sketching a graph, you're always going to have consists of a bunch of lines put together, okay? So remember, the slope of a line is constant, okay? Which means this should be a bunch of constant functions, okay? Meaning horizontal lines. So from time 0 to time 3, my slope is rise 2, run 1, or 2 over 1. Okay, so, or 2. Okay, so from time 0 to time 3, not sure, it is seconds, to time 3 seconds, our slope is 2. So from time 0 to time 3, we're at a constant slope of 2. Okay, why is this an open circle? Remember yesterday, or the day before, we learned that at a sharp turn like this, we do not have a derivative exists, okay? Can't draw a tangent line there. All right, from time 3 to 5, our slope is 0. So from 3 to 5, we are 0. From time 5 to 8, our slope is -1. So from 5 to 8, we're at -1. Can't really get into -1 here because of my numbers there, but let's just pretend this is -1. So from 5 to 8, we are at -1. And then from 8 to 10, we're back to a constant 0. Okay? And that is assignment number 16, notes.